Hello, this is a short video on how to use the graphical method for solving simultaneous equations. Okay, so I'll go through two ways of doing the graphical method and let you decide which one you prefer. Okay, both of them are acceptable. One I think is a little bit easier than the other, but some people find it a little difficult. Okay, so here we go. Method one for the graphical method of solving simultaneous equations is firstly to draw a table of values for each of these equations and then plot the points in that table on the graph and then see where the lines cross, and that'll be our point of intersection. We'll read the x number and the y number, and they'll be the answer to our simultaneous equation. So graphing this and drawing a table of values, x, y, 0, 1, 2, 3, and I just picked easy numbers for them. You can pick any numbers you like, but I like 0, 1, 2, 3 because generally they're good to work with. And now I'm going to do the x plus 3. So when x is 0, that's my first box, my y is going to be 0 plus 3, which is 3. When my x is 1, my y is going to be 0 plus 1, which is 4. 5 and 6. Okay? Now, for my second one, I'm going to draw a little bit more of an elaborate box because I'm going to need to times it by 3, then take away 5. Okay? So I've still got x. I'm going to draw a second line down here, and then the same deal. 0, 1, 2, 3. I'll get rid of that weird line there. Bye, weird line. Come on, goodbye, weird line. Ah, goodbye, weird line. Oh no. Oh, hey, we're back in business. Okay, so 3. Oh no, now it's rubbing everything out. You're gonna love computers. Okay, so back to it. 3x. So 3 lots of 0, 0. 3 lots of 1, 3. 3 lots of 2, 6. 3 lots of 3, 9. Then take away 5. So this is going to be our y value. We've already done the 3x part, and now we're just going to take away the 5. So nothing take 5 minus 5. Nothing take 3 minus, 3 take 5 minus 2. 6 take 5, 1. Proper 1, not minus 1. And 9 take 5, 4. Okay? So, now what we do is we start drawing our lines. So I'll draw the blue line first. 0, 1, 2, 3 up. 1 across. 1, 2, 3, 4 up. 2 across. 5 up. 3 across. 6 up. And that, hopefully I can draw a straightish line on this thing. Cool. Gives us a line. Okay, and now the black line. I'm just going to cross out this 3x because I don't want those numbers there to confuse me. That was really good working out, but we don't need it anymore. Okay, so 0 is minus 5. Minus 1, 2, 3, 4, 5. 1 is minus 2. Minus 1, 2. 2 is 1. And 3 is 1, 2, 3, 4. Oh, it's very difficult drawing straight lines on a glass tablet. hopefully from the proper straight line, haha, you can see, and I'll do this in red because this is the most important thing in the thing, that this part is on both lines. This part satisfies both equations. So now we need to work out what he is, and that'll be our answer. We've got 1, 2, 3, 4 across, and that's in line with him. So x equals minus 4. And then we've got 1, 2, 3, 4, 5, 6, 7 up. Haha, 7 up. So y equals 7. Now just to do a double check, oh sorry, that should be plus 4. Don't know where that minus came from. So just to do a double check, x plus 3 does equal 7. 4 plus 3 equals 7. And 7 is the same as 4 times 3, take away 5. 4 3s are 12, take away 5, 7. So that is a big tick for that one. Okay. So the next way I find a little bit easier, but many people don't. Okay, so if you don't like this way, just do it the first one. I see it as a little bit of a shortcut. Okay. This one is that if x is 0, it's got to be on this line. Okay, this is a line which doesn't have an across part, and x equals 0. Okay, so if I was just to say that x equals 0 and magically made that decision, I'd know that minus y equals 4. Okay, so nothing take y makes 4. So my answer should be minus 1, 2, 3, 4. Minus 4. Okay, so nothing take away y equals 4. So y has to be minus 4. Okay? Now for the second time, I can get my second point by pretending y equals 0. And so I can go x, my x from there, take away 0 equals 4. So 1, 2, 3, 4 across. This is the line where all the y values are 0, and thus this is 0, 4. And that will give me a line. Okay, and again, this is really hard to do on a piece of glass. Okay, so that's this first equation. The second equation is x plus y equals 2. Okay, and I'll do that one in blue just to hopefully make it a little bit clearer in my working out. Okay, so by the same procedure, along this blue line, x equals 0. So I'll go 0 plus y equals 2. Therefore, y equals 2 on this line. Okay, and I'll draw that 2 very big. Okay, this dot here. Hopefully it won't take me a while to erase this again. Oh, play the game, computer. Play the game. Come on. Okay. But and then so 0. Draw anything at all. Technology, why don't you make this easier? Okay, so don't erase it. I want it 0. I don't. Okay, x. Y is going to be 0 because we want the y value now to make our cross. So x plus 0 because we're trying to find the place along the flat line here equals 2, thus it must be 1, 2. Okay, so now we've got our 2 points. Get my ruler. Okay, and draw my line. And I see that they cross at -1. And sorry, this is a little bit confusing with all the lines. Okay, but they cross at y equals -1. And they cross at 1, 2, 3. So I did it down here because that's going to be easier. 1, 2, 3. Yes. So x equals 3. Okay. So just checking. 3 minus 1 is indeed 4. That's my first equation tick. And then 3 plus 1. Sorry, 3 plus minus 1. Had a little bit of conniption there. 3 plus minus 1 does equal. Want to give it a tick? Well, no tick for that one. But and it's a simultaneous solving. Sorry, that's a graphical method for solving simultaneous equations. Now, this is not a great method for solving simultaneous equations. As you'll see, it's very messy, and you need to do a lot neater job at your working out than I have on this thing to make it work. But the good idea is that it shows you what a simultaneous equation actually is. Like, the equations join all the parts of these lines where they're equal, and the part where both equations are true is where they cross. And so it's not a great method for the calculating the maths side of it, but it is a good method for showing what a simultaneous equation actually is. So hopefully that was helpful. That's the graphical method for solving simultaneous equations.